Howdy, folks. We're back at it. We're back at it. What are we learning today? We are picking up, guys. My video editor, instead of just throwing the biggest of problems, you know what I mean? Just weird day off to a challenging start. You know, when things aren't. Sometimes, some days you got the wind in your sail. Sometimes you got to adjust the sail. You know what I mean? But okay, so we've ran through a lot of important material in Python and got real granular with it from loops, lists, dictionaries, and more. Okay, so what we're going to talk about now is sets. Let's look at it. Sets are like lists, but they are unordered and they guarantee uniqueness. Only one of each value can be in a set. So a set, it's like an object, like an array of strings basically, but it's going to automatically cut out any duplicates. So super useful, very useful. There's been very many times where I've used sets. I had a build for a TensorFlow application that would constantly, from the API, it would constantly stream like huge matrices of data. But I wanted to basically distill it all down to like 4 or 5 different colors. Basically, it was showing the body part recognition. I'll have to show it. I have a video somewhere. I think on my Teachable. I know the link isn't up anymore for the TensorFlow recognition. Let's see. TensorFlow recognition, but basically this I'll have to find it at some point. Maybe if I find it or repost the application. Let's see, boom. So TensorFlow recognition. It was at this URL, but I know that I think I have it hosted on a micro T2 instance that I'm no longer paying for. So, but basically what it did, if it would show like the body parts and screens, and the API would stream a huge amount of data, and I would use a set to distill it down to the core things that I wanted, because it would just remove all the duplicates. So I didn't need all the extra thousands and thousands, tens of thousands of extra same arrays within the matrix. I just needed the unique ones, the different ones. So there's yeah, it looks like it's down. So there's good uses for. Now I feel like I gotta prove to y'all that it was real. You know what I mean? Like I gotta prove that it was real, but I promise it was. I promise it was. Maybe I'll find a video or something and clip it in here. But yeah. Let me find a video real quick just to show, because now I feel like a scam, and then we'll hop into the deal. So let me do this real quick. Boom. Okay, so here it is. I don't know how well you guys are gonna be able to see that, but it would show a list of the body parts below right here, and then on the screen it would I'd have like my arm or hand showing. Yeah, so there's a few videos of it, and then I obviously built out the application to look a little bit better. But yeah, it was really cool, because it would like stream a mass amount of data, and then the workaround for it was using a set to distill that data to the core things. So they're very important. So let's talk about it in Python. Sets are like lists, but they are unordered in they guarantee uniqueness. Only one of each value can be in a set. Okay, cool. So print fruits, boom, 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 print type fruits. We have apple, banana, grape. We can add pear, and we would add it to the set. So empty set. Because the empty bracket syntax creates an empty dictionary to create an empty set, you need to use the set function. Okay, so a little different. The brackets, we could do key value stores, but with sets, if we're not doing key values, we're just doing unique values, we need to use sets. Okay, so iterate over values in a set. Order is not guaranteed, meaning they're unordered, I imagine. So it looks like, okay, they're showing that it can print any of the values at will. So to remove duplicates from the function, I suppose we could say, how do we do sets in Python? Here we go, spells, empty set, return spells. Let's see what we got. Return a new list where there is at most one of each title. You can accomplish this by creating a set, adding all the sets. Okay, so we'll say new spells, and then we'll return new spells, add spells, maybe? Well, let's break it down, right? So we'll say for spell in spells. Let's print out the spell, see what we got here, and I'll capitalize the spell. Guys, let me zoom in a bit for y'all. Okay, so we have our spells down here in the bottom right, you can see. Here's all of our fireball. So we have many of the spells repeating. And what I want to say is new. Yeah, I think that's what we wanted to do, right? New spells equals the set. And then we want to say new spells dot add spell. And then we want to return new spells, right? Potentially fail. Okay. So what is new spells now after doing all that? New spells, here we are. So we looks like we're returning it proper, but we're returning a set and they want us to return a list. So how do we make that a list? Because it looks like what it's expecting is here, but this is what we're actually giving is this right here. So we've done the contents part. We've done the logic part. We just need to now make this set a list. Okay, so can we do this as list here and start it with an empty list or an array and then say list dot append new spells, right? Would that work? And then let's print the list and see what we have. We'll delete this other one. Okay, so the set becomes it's nested, basically a nested set within the list, which is not what we want. We want the list here. So what we can do, I suppose, is then do a for loop, and there might be an easier way to do this, but we could say for new spell in new spells, right, and just append it to the list. So list append new spell, and what this should do is just return the new spell in the list, or the unique spell, the only spell in the list. So let's try this out here. Boom, and here we have it. We have, I believe, what we're looking for in unordered way. So I don't know if they want us to do something, but let's see if this passes. Sweet guys, we got there. We did it. We did the deal. I do want to see their solution to see if they did. Oh, they did do 2 for loops as well. Sweet. Okay, so we did the right thing. We did roughly the right thing. We just appended to a spell. Let's see what they did here. So they did duped spells. They duped. That's a fun word. Okay. Oh, they do have another list. They just stashed it right here while we stashed ours up here. Cool. So we hit it pretty much on the nose on exactly what we needed to do, roughly. Okay. How do we remove item from a set? I'm not sure, to be honest. Is it the remove? Sweet. Guys, I've got a wine glass full of water. It's water. It's not wine. I'm not an alcoholic. You know, it's 10 a.m. I don't like to drink alcohol very often at all, if ever. It's water in a wine glass. I'm the bougie boy. You know what I mean? Okay, so what is the type of my val in the following statement? My val looks like that could be a dictionary, right? Okay, so what would be a good use of a set to remove any duplicate possible? I think so. To store all possible spells in a game. Okay, to store all enemies in a game by difficulty, potentially. To store ID user pairs. So that's good for dictionaries right here. That's a good dictionary or array of dictionaries. List of dictionaries even. To store all possible spells in a game. Let's think about that. That could be a good use. Store all enemies in a game by difficulty. That would probably be a dictionary. So this would be a list of dictionaries. This would probably be a dictionary. So I'm going to go with choice B. Looks like we've crushed it because it's just a string list of spells, I suppose. I think it's so funny when I'm like grabbing stuff off screen to pull the drink of like water or coffee. One time I'll just have like 50 different drinks over here. So every time it's like a random cup, like one with like the fruit glasses or something, or like a huge jug or something, would just be so funny. So every time it's like a different glass, like I just had 15 things over here. Would be, I don't know, I have 2, but that would be hilarious. That would be hilarious. Okay, so duplicates. John is a data analyst, but he's bad with code. He has asked for a script that can remove duplicates from some of his data. Complete the challenge. Remove duplicates function. It accepts a list of strings and removes any duplicate values. It should utilize and return a set, not a list. Okay, so if we say new list, it's a set. And what we could do, essentially say new list, add LST, and return new list. Well, let's print it. Let's see what we got here. And we could return it as well. Might as well, right? Where is the list? Unhashable type list. Whoa. What do you mean? Whoa. Okay, so we say new list. What was it? Append? Is it LST? Is that how we do it? No. Add. Oh, you know what? For item in LST. Boom. Here we go. And then we want to add item, not LST. Boom. Okay, now we're cooking with some grease in the pot. Now we're cooking. Okay, and then we can go ahead and return that. That should be our deal, right? Boom. 2 passed, 8 passed. Sweet. Guys, we're cooking. We're cooking a little bacon. A little bacon in the buns, you know? A little bacon in the fire. A little something over there, right? Kind of cross that a bit. Okay, so let's count vowels now. You've been hired by a blogging company, and they are asking you to analyze one of their recent posts to determine the number of vowels present in their paragraphs. Complete the count vowels function. It should take a string and return the count of the vowels given within a string and in a set of its unique vowels. Okay, so we need to take this real quick. So we say vowels equals this. And we need to make each one of these an individual string, because I think what we want to do is just compare this real quick. We can loop this over, I think, and then have a count. Well, hold on, before I get too far into coding, let's talk game plan. So the idea is we need to count the vowels within a string. So we're given a text, right? Hello, my name is Pax. So there's a text within that of like E is 1, O is 1, you know, M, Y, looks like we're not counting Y's, but A is 1, E is my name, I, then A again. So that hello, my name is Pax should have a count of 6. So what we need to do is loop through the string, maybe split the string or loop it through each letter. And we want to loop through the vowels too and check if any of the vowels are in the string. If that is true, then we need to up the count. And then what we also need to do is somehow distill the vowels. Maybe at that point, when we up the count, put it into a set as well. So I think we'll need 2 things. So we'll have a count, we'll have the vowels, and then we'll have vowels uniquely in the sentence, right? Which is going to be a set, not a sate, but a set. I think that'll work. So let's do 4 letter in text. Let's real quick see what we're working with here. This might be words. Here, boom. Okay, so that is all of our letters. Perfect. And I think what we need to do is a nested for loop in this. So we need to check for the vowels. If it's one of those vowels, count needs to go up. So let's muck around with it. Let's see what we got. So for val in vowels, if val equals letter, we want to do count plus 1. And then also what we want to do is say vowel or vowels in sentence, add the vowel. I believe that's all we want, right? So let's put the count here. We'll do count with some stars so we can differentiate it in the console. And then we'll also print the vowels in the sentence, and we'll put that here like that. Okay, cool. So let's see. So some sentence gets passed in. It looks like we don't have all the vowels, which is good. That means something's working here roughly, and the count is 10. So maybe it worked-ish, kind of. No, we have 2 failed. I think we're onto the roughly right idea, but let's see. Let's think a little bit deeper real quick. So, but let's reread the question one more time just to make sure everything's clicking off proper. Oh, of course it's going to fail. Duh, we're not returning anything. Duh. Because I just immediately assumed it failed, so must have mean we're doing something wrong. Let's first return what we need to return, and let's see. So complete the vowels function. It should take a string and return a count of the number of vowels given within the string and its unique deal. So let's first return the count as a tuple, and then we also need to return the vowels in the sentence. Let's see if that passes. 1 passed, 1 failed, so we're halfway there. Oh, living on a prayer. Take my hand, we'll make it, I swear. Watch me get copyrighted for that. I'd be so mad. Golly. Okay, so applications are not normal programs. So expecting 11. Do we start the count at 1? Is that a problem? Expecting 0. Ooh, it's got a capital A. Got it. We got to do 2 lowercase. 2 lowercase. Boom. Believe that's right. Is that not a function? We could just add the capital letters up here as well. So if it's any of these, or we could lowercase and uppercase all of them. We'll do both just for sake of learning. But let's try this one first. So if it's any of these, whether it's lowercase or uppercase, we should still pass. Boom, 2 passed. Looks like we got it crushed there. Nice. That's pretty sweet. So let's say 2 lowercase Python. I thought it was 2. Oh, just lower. Okay, so we could do this way, where we include what we're checking the vowels by both lower and uppercase, or we can also lower the letters. I think that should work too, right? Oh, maybe not. Oh, it's got the count right. Oh, you know why? We actually probably do need to do the uppercase one, because when it's adding it to the thing, it can't be by the lower one, because if we check it by the lower one and then we add that, well, no, it should still add that vowel if the lowercase version equals the lowercase version, because we're not actually changing the vowel. We're just checking if the lowercase version equals the lowercase version. So I'm not sure why it's actually not getting added in for vowel, because we still should see the uppercase vowel here. If not, we'll just move forward, but we still should see the uppercase one, right? Maybe that does mutate the data. Good to know. We learn more. Maybe that does mutate the data even up here. So, okay. So let's just keep it the way it was, of just uppercase and lowercase. We'll check both. Seems to work great. Awesome. Cool. Let's double check. Make sure we're still passing. Great. That's awesome. Okay. So oh guys, we're almost done already. That kind of cruised on by. That was fun. That was a good deal. That was a good old deal. Okay, so differences. Your local gym recently bought out another gym and they're trying to merge their customer data. You've been given 2 lists of customer IDs numbers, and they are trying to figure out which customer from the first gym are not also members of the second gym. This seems like a stingy gym. You know what I mean? Like golly, just migrate the data over. What do you mean? What do you mean? You've been given 2 lists of customers and you're trying to figure out which customers are not customers from the first gym and the second gym. What? Luckily, the IDs from the 2 gyms match up because they use the same backend servers. It's some shimmy sham here. I don't know about these gyms. I don't know about them. There's some shimmy sham here. Okay, so complete the find missing IDs function. It accepts 2 lists as an input and returns a new list of all the IDs present in the first list, but not the second. Interesting. So I'm still unsure of exactly what we're doing. Keep in mind there may be duplicate IDs in those lists. The gym workers aren't exactly concerned about the data integrity. I'm telling you, this is a scam gym. This is Global Gym. This is how Global Gym was built. Make sure to remove any duplicates. Okay, so it looks like we could say first set equals set, and we could go ahead and say for this in this, and we could say first set dot add first ID, right? That should kind of give us our first deal. And then let's do the same deal on the second set. So we'll say for this in that. We could also probably just add it actually to this whole thing. I'll rename it ID set. That just makes a little bit more sense. Say ID set dot add second ID as well. And then we could go ahead and return the ID set. I believe we'll get the job done here. Let's see. Boom, maybe. Fingers crossed. First set. Oh, what are we supposed to return? A list? Returns a new list of all the IDs. Got it. Okay, so then we also need a list of IDs, and we could go ahead and loop through the other set, the ID set. So for ID and ID set, we could say list append, just not add, ID. And let's go ahead and print the list of IDs. Could it be? Potentially expecting 9 and 10. So do we have to figure out the differentiating IDs or the ones that duplicate? Maybe I don't understand the question. I think that's what's going on here is I'm just writing code. I don't really understand the question still. Because this whole gym thing, it just seems like a scam. It seems like an MLM scheme. You know, like they got a second gym that bought out the first gym, but they know about their data. Seems like a scam. Seems like a shimmy sham. You know, I don't know if I'd write software for these people is what I'm saying. Okay, so you've been given 2 lists of customer IDs. They're trying to figure out which customers from the first gym are not members of the second gym. Oh, I see. So I'm combining them, and they're trying to figure out which ones aren't a member of the second gym. I'm telling you, this is a scam. This is a scam, Jeff, because they're trying to, they're trying to freaking, I think I just need to remove them here. It's actually the only thing I need to do maybe. But they're trying to add people to their second list or figure out who's not a member of their second gym, I suppose. Let's see. So basically we want to remove all the IDs for, let's see. So first we want to set the first IDs here. That's what we want to do, right? I guess we could do this way, right? Set the second IDs and then remove, trying to figure out which customers from the first gym. So we have the first ID list, right? So the first gym are also not members of the second gym. Okay, let's start from scratch for a sec real quick. So we're gonna have first gym IDs. I don't know why, it's just like the wording of it's hurting my brain. I don't know what it is. So it accepts 2 lists as an input and returns a new list of all the IDs present in the first list, but not the second. So if I'm understanding it correctly, if the first list says this and the second list says this, they want us to return 1. Is that what I'm understanding? So it accepts 2 lists as input and returns a new list of all the IDs present in the first list, but not the second. Oh, okay, I do think this is roughly what we're doing. So we have the first list. Okay, we have a second list, and make this happen. Great. Okay, so that's what we need to do. Make this happen. So let's think strategy then for a second. So if I build a list in memory of just a list, or I have the second list, and what I could do is remove any item that's equal to the list in the first list. Yeah, right. Yeah. So any 2s, 3s. But the question is too, how would it know to not add the 4? So that might be an important thing too, potentially. So we need to remove anything from the first list, basically, that's in the second list, I think is how we're going to do it. So remove anything from the first list that is in second list, and then return first list, return updated first list. I think that's our rough approach here. Okay, so let's kind of go for that. So remove anything from first list that is in second list. So if I say for second ID in second IDs, if it's in the first list, remove it, right? So we want to do the opposite of a set almost. Let's think about this. Brain's just going like this right now. My brain's just triggering off all sorts of synaptic pathways, trying to get the thing done. Okay, so say updated first list. You know what I could do is just do a nested loop in both, and then if it is in first list and second list, or if the value's not in the first list, add it to the second list. But then that would add the for in this case. So basically, I would check if these two are equal, don't add it. If these two are equal, don't add it. But if these two aren't equal, add it. But then we'd have the problem of having the for. But it would work for the first one. If these two weren't equal, because there's not a 1 in this second list, add it. So that would actually work great. So how do we do include for? Let's think about this. Let's think about it. So for first ID and second IDs, if first ID equals second ID, let's just print first ID real quick, because that'll give us the things that are in between both lists. Oh, and we need to remove duplicates, it looks like. Okay, so before we even get to here, let's just remove duplicates. So we'll say first list. It's going to be a set, actually. And we'll do the second set as well, just to streamline our data. I think would be a decent idea, right? Okay, so that'll at least kind of streamline the data. I don't know if we actually need to do that, but it'll at least start us with something, and then we can see if there's no difference. So let's see. Print the ones that are different, right? Why is it printing so many? So the ones that don't equal, expecting 9 and 10. Okay, so let's start with that. I think this will at least clean up our data a smidge. Let's print the second gem IDs and the first gem IDs. So then we should just be left with like just the core values, no duplicates, which we are, which is perfect. So now we just need to find the difference between the two, which is 9 and 10 here. Makes it a whole bunch easier, So, and then finally we're going to return a list. So there's kind of a lot going on here, but at least we've streamlined the data to just 1 through 10 and then up till 8. And how do we get, basically, the question is now, if it's in the first array, let's see, returns a new list of all the IDs present in the first list, but not the second. So we need to return 9 and 10, right? So maybe we say for, we're gonna put an S on these. So for gem IDs, real quick, just because plural and language matters. So I'll say for first gem ID in gem IDs. And what we'll kind of do a similar deal here. I think just nest them, or can I remove them actually? Can I just immediately remove the sets and say dot remove gem IDs, right? And then print the first gem ID again. Would that work? That would be really convenient. That would be awesome. Let's see. Delete. Oh, you know what? Maybe I need to loop through them. So let's try that. I think that's what we need to do though, is just go like this. For first gem IDs in gem IDs, remove, I guess actually it would be the second gem IDs that we want to remove. Remove the second gem, right? Oh, shoot, I didn't want to see the solution. I don't want to see the solution, folks. We want to get this proper. Okay, so what did this work though? Remove the ones that aren't here. First gem ID. Where are we messing up here? Where are we messing up? Where's the mess up? Let's try this one more time. Oh, we're not returning anything, of course. So no, but why is that breaking now? Why is that breaking? First gem IDs. Oh, I see. I done broke it, folks. That's why. Okay, cool. So we're back to here. Let's see. For first, I think that might have been the right logic. Let's see. For first gem IDs, remove the second gem ID, right? And then let's print this again. Sorry, I'll explain the logic. I just want to make sure this is working, because right now my brain is just like hurting. Sweet. We got there, folks. We got there. Nice. Okay, cool. That kind of worked, right? Well, it did work. And then finally, we need to make it a list. So we'll say answer equals this. I will say for first gem ID in gem IDs, we'll answer dot add this, and then we'll of course return the answer, and that should be our answer. Okay, that should be boom. Answer.add append. Is it? Sweet. Passed. One failed. Okay, we failed one, but we're almost there. We're almost there. We're passing some, we're failing some. Let's see. Let's see where we failed here. But roughly the logic goes something as this, right? So we have our sets. We're going to first purify the data. That's all this first one does. It's just like get rid of all the duplicates, number one. That's number one. The second thing we want to do, and maybe we can combine this here actually, is maybe just stash this one up here, right? Maybe we don't need to do this extra step. Gem ID. No, it looks like we do. 4-second gem IDs. So I could nest this loop up here, but that might be just a little bit too much. But so the first step right here, it's just streamlining both lists. We're adding both these lists to these sets, so we get rid of all the duplicates. So if it's like 1, 1, 2, 2, 3, 4 on one list, and then if it's like 1, 2, 3, 4, 9, 9, 9, 8, 6, like we're first of all just streamlining all the data, purifying it, hashing it to the maps or to the sets, and then we're just starting with our data. So we're over here at this first step. We're just appending unique IDs. So then after this step, let's print again what we got, which we showed a little bit earlier, which is just going to be our list of streamlined data. The second thing we're doing is just measuring this second list of gem IDs. We're pulling out individual IDs and we're removing it from the first list so that we should be left with roughly the answers we need. So 9 and 10, or this is what we're left with. This is our print statement right here. I'll put some stars here to denote that, and that's right there. But you can see it's in an object and they need it as an array. So what we do is just build an array, a quick list that I've just labeled answer, and then we're just looping through that object that we know is the answer or should roughly be the answer. We're almost there. We just need to do one thing to pass. And then we're appending those answers. The same thing. We're basically just saying, okay, it's an object. Let's put it into an array, or it's a dictionary. Let's put it into a list, and we're appending it and returning that. So we're almost there. We're almost there. Now the question is, where are we failing now at this point? So we have failed here, boom. Let's see the failed. Let's see, why is it? So first ID is 1, 2, 3, 4, 5, expecting 2 and 4, and it says the actual is here. So passes that one, passes this one, 4 and 5, passes empty, where's the fail? Oh, here we go. Second IDs, got it. Okay, so we need to add some sort of skip step if there's no second IDs. Let's see. Let's say length of second gem IDs equals 0, return. We can add that in our for loop, I suppose, and do an else statement. So else do this. Let's see if that works now. Nope, we're still failing. Okay, we need that bit. Oh, you know what I could do is say, basically return the... Well, let's see. So if I pass it 1, 1, 1, 1, what would happen? Where's the one that fails? Here it is. So first IDs, it has 3 1s. Second ID is 0. So again, what do we need to replace with? It returns a new list of all the IDs present in the first list, but not the second. So we just need to return the list of this, the hash of that, or the set of that list. So how can we integrate that into this, right? So first gem IDs, and then we could say, I suppose, if length of gem IDs equals 0, return first gem IDs, else return answer, right? Maybe. All right, let's see what we got. We're almost there, guys. I just needed a guard clause for this deal. Let's see. Oh my gosh, you're kidding. We went through all that work and they just did this. Unreal, unfreaking real. Well, good to know. Good to know. You know, there's times where if you do better, you do better, right? You do better, you do better. So that's perfect. That's perfect. You know, we took the long roundabout way, learn some logic, learn what not to do. Basically, step 1, make a set. Step 2, make a set and get the comparison of the two. You could do a list like this. Oh, I don't have to reappend it to an array. Good to know. Good to know. Good to know. Okay, cool. Well, guys, we learned a lot here. So let's keep up the speed. You know, we're gonna hop into some errors and expectations or exceptions, excuse me, which should be fun. And I think we're almost wrapped up with the part 1 of Python. We've really granularly understood a lot about it, which is fantastic. This is going to be an amazing building block to continue the series, and especially when we get to object-oriented programming and just looking farther at the roadmap. Like, you know, we should be cruising through a lot of these sections here coming up pretty quick because there's 60 lessons or 60 bits, or this one's 50 bits. You know, we're averaging about 20, I think, bits per an episode. So we should kind of cruise through a lot of these, and then we'll be on to JavaScript before we know it. And then Golang, I'm super excited for Go. So it should be a good time. I'm really looking forward to the next series or the next episode. I will see you there. Cheers.